Dear students, welcome to my 7th class on Module 2 Fourier Series. In this lecture video, we're going to discuss about the new concept, that is practical harmonic analysis. So what is practical harmonic analysis? The harmonic analysis is a process of finding the constant term and first few cos term and sine terms numerically. So the first concept is Fourier series of period 2 pi of a function y is equal to f of x. The formula is given by f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin nx. So here, to find the value of a naught, the formula is 2 by n summation y, and a n formula is 2 by n summation y cos nx, and bn formula is 2 by n summation y sin x. So to find the value of a1, a2, a3, so I'll be replacing n is equal to 1, 2, 3. Similarly, to find the value of b1, b2, b3, I'll be putting n is equal to 1, 2, 3. So therefore, the formula for a1 will be a1 is equal to 2 by 1 summation y cos x, a2 will be 2 by n summation y cos 2x, a3 will be 2 by n summation y cos 3x. So in the same way, b1 will be 2 by n summation y sin x, b2 will be 2 by n summation y sin 2x, b3 will be 2 by n summation y sin 3x. So the next case is Fourier series of period 2n of a function y is equal to f of x. So the formula is f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos n pi by lx plus summation n from 1 to infinity bn sin n pi by lx. So here, to find a naught, the formula is 2 by n is equal to summation y, a n is equal to 2 by n summation y cos n pi by lx, and bn will be equal to 2 by n summation y sin n pi by lx. So here, we'll be replacing this pi x by n is equal to theta. So now, after replacing this pi x by n is equal to theta, we'll be getting a naught is equal to 2 by n summation y, a n is equal to 2 by n summation y cos n theta, and bn will be equal to 2 by n summation y sin theta. Will be using in the arbitrary interval case. The problems on the practical harmonic analysis. First problem, find the constant term, first cosine and first sine term of the Fourier series expansion of y from the following data. So constant term means we have to find a naught by 2, first cosine term means a1, first sine term is b1 we have to find with the help of the following data. So the data is given like x in terms of degree they have given, that is x is equal to 0, 45, 90, 135, 180, 225, 270, 315. Y they have given 2, 3 by 2, 1, 1 by 2, 0, 1 by 2, 1, 3 by 2. So now here the range of x will be 0 less than or equal to x less than 360, that is 0 is less than or equal to x less than 2 pi. So it is a 2 pi interval and the value of n will be given by 8 here. So like how means the number of data is 8 here, that is x is equal to 1, 2, 3, 4, 5, 6, 7, 8. So the value of n will be equal to 8. So now the Fourier series of y up to first harmonic means we'll be finding this only y is equal to a naught by 2 plus a1 cos x plus b1 sin x only will be finding. So this is constant term, first cos term, first sine term. So now we have to find the values of this a1, b1 and a naught. So to find a naught, so the formula will be actually what 2 by n summation y. To find a1 the formula is 2 by n summation y cos x. So to find b1 the formula is 2 by n summation y sin x. So now our job is to find the value of y cos x and y sin x. So first take all x data here. So x in terms of degree, that is 0, 45, 90, 135, 180, 225, 270, 350. And take all the y values also with respect to all the x values, that is 2, 3 by 2, 1, 1 by 2, 0, 1 by 2, 1, 3 by 2 they have given. So now I'll be finding cos x and sin x. So cos 0 will be 1, cos 45 is 0.7071, cos 90 is 0, cos 135 is minus 0.7071, cos 180 is minus 1, cos 225 is minus 0.7071, cos 270 is 0, cos 315 is 0.7071. Similarly sin x. So sin 0 will be 0, sin 45 is 0.7071, sin 90 is 1, sin 135 is 0.7071, Sine 180 is 0, sine 225 is minus 0.7071, sine 270 is minus 1, sine 315 is minus 0.7071. So now we'll be finding y cos x and y sin x. So this entire y values I'm going to multiply with each cos x, and the each y I'll be multiplying with each sin x. So now y cos x will become 2.0, 1.06065, 0 minus 0.35355, 0 minus 0.35355, 0, 1.6065, and similar y sin x also, multiplying each y with each sin x values, that is 0, next one is 1.06065, 1, 0.35355, 0 minus 0.35355, minus 1 minus 1.06065. So now I'm going to find summation y. Adding all the y values, we got summation y is equal to 8. Adding all summation y cos x, we got the summation y cos x is 3.4142. Adding all summation y sin x, we got the value 0. So now our job is to find the values of a0, a1, b1. Okay, the formula for a0 is 2 by n summation y. So 2 by 8 into 8, the value of a0 will be equal to 2. a1 is 2 by n summation y cos x, that is 2 by 8 into 3.4142. So a1 will be 0.85355. b1 is 2 by n summation y sin x, so 2 by 8 into 0, so b1 will be 0. So now replace this a0, a1, b1 in the main formula. So we got y is equal to 2 by 2 plus 0.85355 cos x plus 0 into sin x. So y will be equal to 1 plus 0.85355 cos x is the first harmonic. Example number 2. So the problem is given like x in terms of degrees 0, 60, 120, 180, 240, 300. Y is given like 7.9, 7.2, 3.6, 0.5, 0.9, 6.8. So we have to find the value of only first harmonic with the help of the Fourier series. So we'll find that. So first harmonic is same like a previous problem. We'll be finding a0 by 2, a1 cos x and b1 sin x. So here the range of x will be 0 less than or equal to x less than 360, that is 0 less than or equal to x less than 2 pi. And in this problem the value of n will be equal to 6 they have given. So now the Fourier series of up to first harmonic is given by y is equal to a0 by 2, a1 cos x plus b1 sin x. So now make a table, find all the values of y cos x and y sin x. So x is given like 0, 60, 120, 180, 240, 300. Y is given like 7.9, 7.2, 3.6, 0.5, 0.9 and 6.8. So now I'll be finding cos x. So cos 0 is 1, cos 60 is 0.5, cos 120 is minus 0.5, cos 180 is minus 1, cos 240 is minus 0.5, cos 300 is 0.5. So now y into cos x. So each y value I'm going to multiply with cos x. So 7.9, 3.6, minus 1.8, minus 0.5, minus 0.4 pi, 3.4. So now finding sin x. Sin 0 is 0, sin 60 is 0.866, sin 120 is 0.866, sin 180 is 0, sin 240 is minus 0.866, sin 300 is minus 0.866. So now multiplying y into sin x. So each y value I'll be multiplying with sin x. So 0, 6.2352, 3.1176, 0, minus 0.7794, minus 5.888. So now finding summation y cos x, summation y sin x, adding all y. So we got summation y is equal to 26.9. Adding all y cos x, we got summation y cos x is 12.15. Adding all y sin x, we got summation y sin x is 2.684. So now finding a0, a1, b1. So the formula for a0 is 2 by n summation y. So we got 2 by 6 into 26.9. So the value of a0 is 8.9667. Now a1, 2 by n summation y cos x. So 2 by 6 into 12.15. So the value of a1 will be 4.05. So b1, 2 by n summation y sin x. 2 by 6 into 2.6846. So b1 will be equal to 0.8941. So therefore y will be equal to 8.9667 by 2 plus 4.05 cos x plus 0.8949 sin x. So therefore y will be equal to 4.48335 plus 4.05 cos x plus 0.8949 sin x is the required first harmonic for the given data. Okay, in the next lecture video we will be discussing few more problems on the practical harmonic analysis only. Thank you.